So let's talk about the cubic under a radical. And you might say, Ms. Sorensen, I don't see a cubic. But the thing is, this is to the degree of 1, and then this is a squared. So if you were to actually multiply this entire thing out, it actually would be x cubed as your leading degree and term. So as a reminder, and this is something I want you to get down, the graph of x cubed looks like an S, and we actually do need to know that for this problem. So if I had x cubed, it's going to look like an S and do something like this. If I have a negative x cubed, it's going to flip, and it's going to go down first, then come up, and then end here. So that's really important to know. And that's really the first step here, is to identify which S curve it is. Now this has a positive, in fact there's nothing written, but it's a positive 1. So we know that this example is going to look like this. Now we can also find where it hits the graph by looking at what our roots are. And here we're going to have an x equal 2 as a root, and here we'll have an x equals negative 5. Now, I don't know if we've talked about this before, but if you have a squared like this, it actually bounces at that point on the x-axis. So if you're not sure what I'm talking about, let me show you right now. First thing that we're going to do is we're going to label our 2 and label my minus 5, and it's going to bounce here. Okay, you might even want to put in parentheses bounce. But if it has just a degree of 1, it's just going to cross. It's not going to bounce at all. So it's going to look something like this. It's going to start down below. It's going to start down below. It's going to bounce, meaning it's not going to cross. It's just going to go like that. But then we know it crosses at 2. The reason we know it crosses is because of this degree of 1. So now this is just like the other problem. Remember, for radicals, we need to have greater than or equal to 0. So our only good places would be here and here. So we're going to have from negative infinity to minus 5 union 2 to infinity. All right. So a quick summary of how to solve these problems would be to identify shape. Okay, and what I mean by that is it going to be this or is it going to be that? Find the zeros. Okay, and we find that by basically doing the opposite of this, or saying it equal to 0. Graph, and then you want to write the interval where it is above the x-axis. Okay, all right, get that down. Let's try another one. Okay, this is another example where we've got a positive 1 out in front, which basically means it is going to be the shape like this. So that's our first step, identifying the shape. Okay, next thing we're going to do is we have an x equals minus 3. Okay, and an x equals 4. Now at the 4, because of the squared, it's going to bounce. Okay, so what is this going to look like? Well, it is going to start down here. It's going to hit the 4 and bounce. That was a bit dramatic, sorry. All right, so there's our graph. And the question is, where is our graph greater than or equal to 0? Well, actually, the entire top half here. Here, 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 here. And it's going to be equal to 0 there, but no big deal. So we actually are going to have the domain from negative 3 to infinity, because we're talking about all this to the right. Okay, one last problem to try. Kind of a short video here. Okay, now here I have a negative. So as a reminder, this is going to look a little bit different. That's going to be the flip of that. So I'm going to have, it's going to go like this, like that. Okay, we know that we have an x equals 5, and we know we have an x equals -2, and then we do have a bounce here because of the 2. Here we have a 1, so it crosses. So let me label my -2. Let me label my 5. And now to graph this, okay, I know it starts like this, so it's going to start and it's going to, which one was my bounce? This one was my bounce. So I'm going to go down, hit, whoop, and then it does something up there, and then it goes back down. So the places where this is actually greater than or equal to 0 is going to be right here. So that's going to be from -infinity to 5. And we can include 5 because it's equal to 0 at that point. All right, that's it. Cubics under a radical.